Good morning. I'd like to thank the organizers for inviting me to this wonderful workshop. I'd like to just remind people that the presentation is going to be including some unpublished material. It'll be indicated on those slides. I'm going to ask you please to not redistribute that material. My title really reflects the emphasis of what the presentation is, and it's a slight modification of what was suggested to me. So we're going to be discussing the onset of puberty, obesity, and endocrine-disrupting chemicals. So what is puberty? We've heard about it a little bit earlier this morning. So puberty is a series of interrelated changes. It involves just about every system in the human body. It is the only time in postnatal life that there's an acceleration in growth as they go through their pubertal growth spurt. There's profound changes in body composition that was just alluded to in the last couple of minutes. Although we think about the maturation and the reactivation of the hypothalamic pituitary gonadal axis and its reactivation because the full-term infant has a fully functioning HPG axis that gets turned off for some reason in the first 6 months of life. But we often forget about the hypothalamic pituitary adrenal axis, which I think is critical to part of puberty. And also, so most of my time is actually spent as a clinician, and I'm trying to stop the achievement of the ability to reproduce in the adolescent clients I serve. People have suggested that puberty could be considered as a window of susceptibility in both ways, that puberty could be a sensitive window to environmental exposures that are occurring, so the timing of puberty being affected by what's going on outside, but that puberty itself could serve as a special window of susceptibility to later adult morbidity and mortality, such as with breast cancer. Just so that we're all talking about the same terms, and sometimes these terms are used interchangeably and sometimes incorrectly, let's go talk about some vocabulary. So adrenarche is the activation of the adrenal cortex. There are changes that occur at the molecular level within these cells, where there's a conversion of the glucocorticoids into the production of the adrenal androgens. Pubarche is the appearance of pubic hair, or pubic hair stage 2, PH2. Thelarche is the appearance of breast tissue, or breast stage 2. Stage 2 for both of these in reflection to a series that had been proposed by Dr. Tanner, actually earlier by Reynolds and Wines back in the 40s. And so 2 is that first stage into puberty. Gonadarche is the appearance of secondary sexual characteristics and traditionally has been defined as the gonadal production of sex steroids. Although perhaps some of the newest findings with puberty suggest that there may be extragonadal sex steroid production, kicking some of these girls off into puberty. And I see some people looking at me like, what? Wait for a couple slides. And then menarche is the age of the first menstrual period. This is the sequence of events, and I'm going to be going through for girls right now. This is the sequence of events. This comes from the Growth and Health Study, which recruited girls back in the 1980s. So down here, you would be, actually off the slide, there would be adrenarche, that is the activation of the adrenal hormones coming from the adrenal gland. The first sign would be an increase in ovarian volume, something that clinicians we can't really see. But with that would be the entry into the pubertal growth spurt. Typically in girls, we then define the onset of puberty as the appearance of breast stage 2 more often than pubic hair stage 2. But this occurs distinctly after the entry into the pubertal growth spurt. About a year and a half or so after the onset of breast stage 2 is the peak height velocity, and 6 to 12 months after that is the first menstrual period. The completion of puberty occurs out here, and again, the attainment of breast stage 5 or pubic hair stage 5, but there's still a little bit of growth that occurs even after the attainment of what appears to be full pubertal maturation. Several studies, multiple studies, have reported on the association of obesity with earlier breast maturation in girls. And our study about a year ago proposed that in this group, this cohort of 1,200 girls, that body mass index accounted for 14% of the variance in the age of onset of pubertal maturation. In this study, 5% was accounted for by race and ethnicity. This is the first study in which BMI actually was a more important contributor to the onset of puberty than race and ethnicity. So back in 1974, Rose Frisch proposed that when kids attained a critical weight, and about a year or two after that, suggested that it was a critical body fat, that they would both go into puberty and at a higher level would start having menarche. And many people after that said that the data were incorrect. About in 1997, Matkovich noted that, well, actually there is this relationship between leptin, and a hormone produced by the fat cell, with the association of earlier menarche, and reported that for every increase in serum leptin concentrations of 1 nanogram per ml, that the age of menarche dropped by 1 month. Grumbach, a little over a decade ago, said, well, if you take a look at the studies with leptin, clearly leptin is necessary, but it is not sufficient for kids to go into puberty, and that there's got to be a different mechanism. That mechanism was defined or proposed to be the GnRH pulse generator, a series of neurons that are collected near the hypothalamus. And a couple of years ago, Bianco reported that increased adiposity was associated with earlier activation of this LH pulse generator, that is the gonadostat, if you would. Again, I'm going to be talking about in greater detail the description of our study, but the solid blue line all the way on the right-hand side are the data that were published by Marcia Herman Giddens back in 1997. When the data came out, it was suggested that this couldn't be true, that this was too early, that there had to be a lot of bias in the study. There are several subsequent studies, including, for example, N. Haynes, and also the data that came out of the NHLBI Growth and Health study that confirmed Herman Giddens' study, that there was the earlier onset of breast development in girls. So that was published in 1997. So about 15 months ago, we published these curves. And looking at this, I'm colorblind, I have to confess. So this dash and 2 dot line there is the curve that is represented by our girls, the white participants in the BCRP. And that you can see that the curve has entirely shifted about 8 months earlier. And this matches up well with the Copenhagen puberty study, where the same researchers using the exact same methodology reported that the age of onset of breast development dropped by 11 months over the course of 16 years. So sometime over the past couple of decades, the age of onset of breast development has decreased. Now, somebody's going to argue, wait a minute, this is a conference that includes obesity, and the girls in your study are on the other side of the obesity epidemic from the girls that were reported by Marcia Herman Giddens. And so what we did was we looked at girls that were below the 85th percentile BMI, and it is a mean BMI that compares favorably with Marcia's study. And even in this dashed line, that it is still translated down. And we've proposed that perhaps this movement down to the left to these younger ages could represent some environmental exposures that we're now evaluating. And you're asking what this curve is? These are the girls that are above the 85th percentile. And this is the age that they're going through with breast development. And if you take a look at the median here, it's a little bit under the age of 8 years of age. The onset in puberty and adiposity in boys is a little bit less clear-cut. In fact, there's about 14 papers that have examined this. 4 of the papers say that higher BMI leads to an earlier onset of puberty. 7 of them say that higher BMI leads to a later onset of pubertal maturation. And there's a few that say we're not exactly sure. Typically, the European studies are suggesting a little bit earlier, the American studies a little bit later. But what I would propose to you is that perhaps this is more like a J-shaped or U-shaped curve, and that an increasing BMI leads to earlier onset of puberty until you get into obesity. And then with obesity, there is a delay in the onset of pubertal maturation in boys. This complex slide, and I apologize to Drs. Ahmed, Ong, and Dunger, because if they looked at this slide, they'd say it looks a little similar to what we proposed a few years ago, made some modifications, but that what they suggested that, we've heard earlier that inadequate prenatal girth, that is growth, birth and growth, girth, it actually is. Birth and growth does lead to girth. So it is the small for gestational age babies have a higher propensity towards obesity. We've discussed the energy imbalance, and we've also introduced the idea of endocrine-disrupting chemicals, all working on this visceral adipose stores. With greater visceral adiposity, there's greater levels of leptin. This association has been demonstrated that there's, in animal models, in the fat cells, increased levels of aromatase. Going back to your physiology and biochemistry, aromatase is the enzyme that converts androgens into estrogens. And with increased visceral adiposity, lots of studies, both in humans as well as animals, show that with increased visceral adiposity, there's insulin resistance and elevated insulin. Insulin resistance and elevated insulin acts directly on the adrenals and increases the production of the adrenal androgens, leading to earlier adrenarche. It acts on the liver to lower the levels of sex hormone binding globulin. Well, if you have lower levels of sex hormone binding globulin, that means there's a greater bioavailability of the sex steroids that are available. That is, for a same serum level of estradiol, if there's less sex hormone binding globulin, then there's more bioavailable estrogen. So elevated levels of insulin do act on the ovaries and lead to increased androgen production, and this pathway has been suggested as one of the mechanisms for the higher rates of PCOS with obesity. Oh, and then I did talk about the increased aromatase and suggested that this could lead to earlier thelarchy, perhaps through a mechanism that does not involve the ovaries. This paper was published a couple months ago in Journal of Clinical Endocrinology and Metabolism. So we used a tandem mass spec HPLC mechanism, which increases the level of sensitivity of the measurement of estradiol by almost tenfold. So your traditional limit of detection occurs right around in here. And what we did was we examined the girls either who are above the median BMI or below the median BMI. And the girls who have a BMI under the median had this robust increase in serum estradiol levels, the same that you would see in most of the published papers about sex steroids in puberty in girls. But among our overweight girls, and this is overrepresented easily by our overweight girls. In fact, over 2/3 of these girls are either overweight or obese. And you can see that their estradiol level hardly bumps as they go through pubertal maturation. And now people are nodding their heads and also shaking their heads like, well, how do they go into puberty? So when I first looked at that, I was watching sci-fi, and I thought we just wasted a lot of taxpayers' money. And then I recalled that the obese women have higher rates of breast cancer. That mechanism has been proposed to be through the conversion of adrenal androgens through aromatase in the fat cells. And it's the greater stores of fat cells that are leading to a higher conversion of the adrenal androgens. And so what I would suggest to you is that what's happening in the intracrine system, that is, this is now the cellular system, the cell talking to cell system, that there may not be estradiol that's being released in the peripheral circulation, but there's still estrogen that's being produced and acting on the growth plates, because we know from our analyses that these girls are in their pubertal growth spurt. We also know that they have breast tissue. In our study, we palpate breasts so that we know that there's glandular tissue there. We just don't do inspection, but you also do palpation. So these girls are having estrogen effect, but they're not having this bump in serum estradiol. And so we've proposed that it is through, perhaps, this conversion of adrenal androgens peripherally that's giving the estrogen effect. So now a little bit about the study. So the RFA went out about 13 or 14 years ago to collect markers of breast development and other physiologic changes of sexual maturation, to look at environmental stressors, to somehow see how this could be translated into future breast cancer risk. And those stressors would include lifestyle, nutrition, anthropometry, as well as exposures. There were 3 sites for the BCRC, BCRP. Those were in East Harlem, and the PI on that was Mary Wolf at Mount Sinai School of Medicine. They recruited girls at neighborhood health centers and in schools. The girls were 6 to 8 years of age at the time of recruitment, and they saw them every year. The second group is through Kaiser Permanente of Northern California. Larry Kushi is the PI, and they recruited families through the Bay Area for who belonged to Kaiser Permanente. The girls were again 6 to 8 years of age, and they were also seen every year. Our study looked at girls in the greater Cincinnati area. We recruited from schools, and we also recruited a group from who had mothers and/or grandmothers and aunts from the Breast Cancer Registry of Greater Cincinnati. We saw the girls in their schools, or we saw them at Cincinnati Children's, and we recruited girls only at 6 to 7 years of age, and we saw them every 6 months because we wanted to more precisely capture the onset of pubertal maturation. Over the course of 2.5 years, we recruited over 1,200 girls. The age of enrollment, most of the girls were 6 and 7 years of age. The race and ethnicity, about equal proportions of black non-Hispanic, white non-Hispanic, and Hispanic girls. There were relatively few Hispanic, I can't tell you which is which because, again, I'm colorblind. There were relatively few Hispanic girls recruited in Cincinnati, and there were no white participants recruited at Mount Sinai. So this is taking the coals back to Newcastle here at the NIEHS, but just to talk again a little bit about endocrine-disrupting chemicals. So they interfere with hormone biosynthesis or metabolism, so either how they're made or how they're broken down. Or they act on the hormone receptors, sometimes as agonists, sometimes as antagonists. The direct effect may depend on timing and/or on gender. So for example, Adjent a couple of years ago reported that soy formula consumption led to earlier menarche. But Cheng, looking at the Dortmund, Germany cohort, and Mervish, looking at our cohort, reported that there was a half a year to 7/10 of a year delay in the onset of breast stage 2 with greater isoflavone consumption. So isoflavones here leading to earlier maturation, and isoflavones here leading to later maturation. Again, the timing may be the critical piece. This bottom part, the molecular mechanisms of endocrine-disrupting chemicals, is not meant to be an exhaustive discussion because we would be here till the afternoon if we reported on all the things, but rather just to give you a flavor of some of the things. So that bisphenol A has been associated with increased aromatase activity, that the phthalates and the perfluorochemicals with decreased activities of 3-beta hydroxysteroid dehydrogenase and 17-beta dehydroxysteroid dehydrogenase. This is important for the conversion of estrone to estradiol and androstenedione to testosterone, and this with the production of the sex steroids. We also know that in animal experiments that bisphenol A can't be 5 more minutes. I've went through a time warp. Leads to a stimulation in the gene transcription for KIS1. KIS1 is proposed as the hormone leading to onset of puberty. And BPA also leads to decreased expression of inhibitors of puberty. So I'm going to now show you some of the data from our study. So phthalates, typically you look at urinary metabolites. You do that because often you would, in your collection, there would be a contamination from the parent compounds. This looks at current exposure. That is, it looks at the last 12 to maybe 72 hours of exposure. Phthalates have 2 general categories, low molecular weight, and this is in the fragrances and personal care products, and high molecular weights. This is the soft plastics, the sealants, the flooring, the rubber ducky, the new shower curtain. Those are the smell of high molecular weight phthalates. Several studies have noted an increase in body mass index and waist circumference, and Teitelbaum, our studies suggest that it was only in, that was only the Mount Sinai girls, that it was only in overweight girls, that there's been a study reporting in kids of an increased insulin resistance with the high molecular weight phthalates. We reported that there was an earlier onset of breast development with the low molecular weight phthalates, but when we looked at it, it appeared that that mechanism was through an increase in BMI. That is, that the low molecular weight phthalates led to a higher BMI, and that was the mechanism that led to earlier onset of pubertal maturation. There's been two studies, both Fredrickson with Copenhagen and our study with later onset of pubic hair stage 2 with the high molecular weight phthalates. And the high molecular weight phthalates have been proposed as being anti-androgens, and this would then be perfectly consistent with that mechanism. And this is looking, again, at our paper that was published just a few months ago, and the, here's the effect in the normal weight girls with the higher levels of the diethyl hexylphthalate leading to later onset of pubic hair 2. And in the overweight girls, again, they have earlier onset of pubic hair 2, and the effect is a little bit less consistent. So a greater effect in the lower weight girls than the high weight girls. Phenols. Phenols are also ubiquitous compounds. They can be used as antiseptics. They're used for monomers, for polymers. They're used as sunscreens such as BP3, mothballs, hand sanitizers, so waterless hand sanitizers. You get your daily dose of phenols through triclosan. Phenols also include the phytoestrogens. They're polyphenols. And when you get that cash register receipt or your credit card receipt and you're picking it up, you're exposing yourself to BPA and BPS. The other thing is that BPS had been used as a pharmacologic estrogen. It was replaced by diethylstilbestrol. So BPS was produced as a pharmacologic estrogen. The Chapel consensus statement says that, okay, we do believe now that BPA is leading to impact on the human body at many different levels. And you can see that a lot of them are with hormone systems and brain structure and chemistry. So very, very briefly, this is sunscreen, BP3, and that you can see that looking at age of B2, that there's an impact here of those with greater levels of BP3 going into pubertal maturation a little bit later. Here's enterolactone, the same effect. Again, this is a phytoestrogen, and this is something that we sort of would have expected. Here's 2,5-dichloro mothballs leading to an earlier onset of breast development, and triclosan also leading to an earlier onset of breast development. And again, these two past slides are not, they've been submitted for publication, so please do not redistribute them. Perfluorochemicals. So this is, this is something that has come to our attention over the past 10 years. PFOA, wide consumer application, grease repellents and water stain repellents, and also in industrial applications in the production of Teflon. Haynes has demonstrated that PFC is widespread in our population, and there have been a couple papers now showing the impact. And so this very complicated slide shows that the earlier onset of breast development is with the higher BMI. Here's the later BMI, but here we see that PFOA does have an impact on the onset of breast development, especially among the lower weight, normal weight kids. I was told to stop, and I'm on my last slide. So the things that, just to think about some future directions, it's thinking about some of the replacement chemicals. So BPA has been pulled off the market and replaced quite a bit by BPS. PFOA has been pulled off the market and replaced now by PFUNA. Something that we've talked about already is that I've just reported on single compounds, yet we live, for better or worse, we live in an ocean of compounds, and that it's much more difficult to try to sort through what's happening with the mixture of compounds. And that something that we've heard a little bit about earlier and we'll hear about later this afternoon is the role of obesogens. I'd like to thank you for your attention.
So we have time before the break for one clarifying question. Is there someone who wants to ask one? That's why I'm allowing you one question here, right? Lynn, go ahead.
what strikes me in hearing your presentation is the effort that you've been going through to disentangle the effects of these compounds potentially on obesity, the effects of obesity on breast development, and the potential to directly have effects of these compounds on breast development. And I wonder if you guys have considered alternative approaches to modeling, like structural equation modeling or other approaches to attempt to get at that. It's very difficult.
So thank you for that question. So we've collected a vast amount of data on these girls. It includes both 24-hour diet recalls and dietary patterns. We've done a lot of anthropometric examinations, as I've sort of suggested with some of these slides. We've looked at, urine and serum biomarkers in these girls, and we've also examined, in Cincinnati at least, some of the sex steroids. And so that you're right. It's going to, and we've measured fasting insulin and glucose. So it's going to take, right now we're sort of dealing with 2 and 3 parameters at a time, and after we sort of sort through those, then we'll start looking at these much more complicated models. And again, these are only going to be associations. We've not fed these to our girls, but these are associations. But I think that after we control for some of these other mechanisms, and indeed may start exploring how these mechanisms are related to each other, that we'll start getting a better story about these exposures.
Well, and if I may add to this, and in terms of the comment that was made earlier about the ability of epidemiologic studies to find, to provide information about causality, I think, of course, DES is an example where the epidemiology studies did identify the causal relationship, so that they often do, but also that the numbers of biomarkers that you're measuring and the ability to use biomarkers to not only assess exposures more precisely, but also mediating events, I think has been a real game changer. And I think it's very much changed the role of epidemiologic studies in being able to elucidate those kinds of associations. But again, I thank you. It's a great presentation.
Thank you very much.
Well, Frank, I actually always thank you because you do a great job. But I really don't have a question. I have an announcement because Gwen said only one last question. So we are running a little behind. I did want to announce several people have taken me up on my offer that they'd like to see a little bit of NIEHS. So at 1:15, which is halfway into lunch, eat quick and join. We'll be having people taking you around. Meet us by the guard's desk right at the front at 1:15. Thank you.
Okay, great. So we are actually right on time. And we're going to take our break. And for those of you on the web, watching the webcast, we'll be back here at 11:20.